Hello, everyone, and welcome to today's press conference. We're announcing our NVMe over Fabrics test service and NVMe over Fabrics Integrators List. My name is Mara Bernazzani. I'm the Communications Coordinator at the UNH Interoperability Lab. I will serve as your moderator today. Our speaker today will be David Wolf, Senior Engineer in Data Center Technologies here at the IOL. After his presentation, we will have a Q&A session. We encourage everyone to submit your questions at any time during this presentation by using the questions box on your screen. We'll collect all of these and address them during the Q&A session at the end of David's presentation. Just a little housekeeping before we get started. The hashtags for today's press conference are hashtag NVMe, hashtag NVMeoF, and hashtag UNHIOL. For those joining by phone, please be sure to mute your line and do not put the conference on hold. Okay, so let's get started. I'd like to now turn this time over to David.
All right, thank you, Mara, and thanks everyone for joining. Got some exciting things to talk about today with respect to NVMeoF. There's been a lot going on in the storage industry in the last couple of years with respect to NVMe itself. And so now it's exciting to see NVMeoF getting some traction. So we're going to talk about some of the things that are happening there and the activity that UNH-IOL has going in that space. So the primary news, we'll be talking about the testing services that we're launching for NVMeoF, also the integrators list that we are launching for NVMeoF. And all of this kind of follows and is in support of some larger goals, both for UNH-IOL and the NVMe and NVMeoF communities, of having industry-wide interoperability, industry-wide collaboration across these kind of disparate technologies, and of course, building an NVMeoF test bed here at UNH-IOL to kind of serve as a center for interoperability. So in order to build on that news and to kind of fill you in on the details of what's happening, we're going to do a little bit of a review of NVMeoF, kind of what it is, because it is a new technology and there's some nuance there. Again, talking about the services and integrators list that we're doing. And then at the end of the presentation, just a little bit about UNH-IOL, who we are and what we do. I recognize that several of the folks on the call are familiar with UNH-IOL, but just a little bit of a primer for those of you who haven't talked to us before. So a little bit of what is NVMeoF and why does it matter? So as I said, there's been so much interest in NVMeoF and so much adoption of NVMe over the last few years. And NVMeoF is really a vehicle that allows companies and enterprises to just take so much more advantage of NVMe. So this little diagram that we put together kind of illustrates the advantage of NVMeoF and what it enables you to do with NVMe. So if you think about NVMe today, there's, of course, lots of folks that are using NVMe in client PCs, desktop laptops, even mobile devices have NVMe drives in them. And they all use a PCIe interface. And that's kind of the primary way that we think about NVMe today. And that's very accurate. So lots of people use that, even just single drives within a system. There's servers on the market that have multiple NVMe drives, multiple NVMe bays, U.2 bays in them, so tens of drives within a single server. There's a few people that are using external PCIe cables to link together multiple storage arrays and servers within a rack. But PCIe, it does enable you to do some external connection, but it was never really meant to be, long distance or wide areas. So even if we connect some racks within a server, we're still only really connecting hundreds of drives. What NVMeoF does is really scale things much, much farther. So instead of restricting NVMe traffic to being just on that local PCIe bus, it allows you to map that NVMe traffic over a fabric. And the common fabrics that we're seeing right now are RoCE, RDMA over Converged Ethernet, as well as Fiber Channel. And this really allows you to scale the number of drives that you can connect to a system and the number of drives that are going to appear local to a system to the tens of thousands of drives. And so now it's not just that, hey, we have this NVMe, this high performance flash storage locally. and having it literally be local. But now we can have it on a data center scale, on the whole other side of a data center, and it still appears local. So it just really allows you to connect to so many more NVMe drives. Now, of course, those individual endpoints, those individual drives, are still connecting over a PCIe interface, but the traffic to them is being mapped over a fabric protocol. And so that is what enables that wider access. Well, who cares about this? Who actually wants NVMeoF testing? Who's involved in creating NVMeoF products? We'll try and answer that. First one, silicon providers. So you'll see that a lot of folks that are involved in fiber channel and Rocky Ethernet networking silicon guys, they're very interested in showing that their products can be used to access storage using NVMeoF. So they're doing conformance testing with us. They're showing that their product, the silicon, can actually be kind of the foundation of building an all-flash appliance or some kind of NVMeoF storage node. And so they've really been kind of the vanguard in this. They've been the ones that are kind of putting their products out there first, putting out tutorials to say, hey, this is how you can use a Rocky NIC or a fiber channel HBA and turn it into an NVMeoF target or turn it into an NVMeoF initiator. So that first group is silicon providers. Second group is software and virtualization providers. So these are folks that they might be building some software management application or storage management application, and they want to make sure that it can work on a variety of hardware. So they want to have a little bit of, be somewhat hardware agnostic, that they can use any one of these different silicon providers products, and their software can manage it, that they can work with a wide variety of NVMe end drives or SSDs at the periphery of the fabric. And so they have an interest in seeing NVMeoF testing and NVMeoF interoperability as well. Third group of folks is the solution providers. So they want to see that, hey, all these pieces, when put together, actually work. So these are the folks who are going to be taking a NIC or an HBA, a switch. They're going to provide the cabling even for all of that. They're going to do any kind of tuning that needs to be done for the Rocky network and handling congestion and all that. They're going to provide the know-how for that. And they're also going to provide that all-flash array at the end and the drives that go into it. So they've got a lot of pieces that they're trying to put together and make work. NVMeoF is one part of that. So solution providers, very interested in this. And then finally, end users. So people are actually buying this stuff and they want to understand NVMeoF is a new technology. How does it work? What are the benefits of it? What kind of testing has been done on it to prove that this stuff is reliable and this stuff is interoperable? So that's kind of the fourth group of people that really care about this thing. So a couple things to keep in mind about NVMeoF, kind of a little primer again. First, the specification, NVMeoF specification that's been created by the NVMe org is designed to be fabric agnostic. Now, what that means is that really anyone can create a binding specification to show how to map these NVMe traffic, NVMe commands, NVMe data, and map it over any other fabric. And so that's kind of what you've seen. Within the NVMeoF specification, they call out a binding spec for Rocky, and they call out a binding spec for InfiniBand. Fiber Channel, the T11 community, they came together and created a binding spec for Fiber Channel. And so NVMeoF, the thing to remember here, it can be mapped onto really any fabric where there's a community. But again, the ones where we've seen the most traffic recently and the ones that our recent Plugfest focused on were Rocky and Fiber Channel. Another thing to keep in mind about NVMeoF is kind of the target latency that they're going for. So they're very interested in trying to get latency to a remote drive connected over fabric to be no more than 10 microseconds greater than what you would get over a locally connected NVMe drive. So think about that. I've got a local NVMe drive in my system or in my server. It's connected over PCIe. I have a certain latency that I have come to expect from that. Now I'm connecting another NVMe drive over a Rocky fabric, over a fiber channel fabric, and I know that the latency is going to be greater. But the target here is to have that be no more than 10 microseconds greater, which is pretty impressive. So a little bit about the PlugFest that we did. We did some work with NVMe.org, a lot of work with them on preparing the PlugFest, outlining what kind of test this was going to be. Also with Fiber Channel Industry Association, and working with them and defining what this testing was going to look like and what things that we would be doing. And from both of these organizations, we came up with a set of conformance requirements today that relies heavily on the NVMe base spec. So basically, our conformance tests look at, since we've mapped the NVMe protocol over this other fabric, does that protocol still behave as we expect? Does it do all of the read and write commands work properly? Do the compare and format commands, all those things work as you would expect, the same over a fabric as they do over regular PCIe interface? So that's kind of the first half of the testing that we did. And then the second half was the interoperability testing. So this is a case where we actually built a small fiber channel fabric, built a small Rocky fabric, and ran I/O, did cable pulls, read to discovery, power cycle, things like that to kind of test and stress the robustness of that small fabric and make sure that indeed NVMeoF performed properly. So as part of that, and to support that kind of ongoing work, we're actually building a library of NVMeoF initiators and targets for both Rocky and Fiber Channel that our member companies can come and test against, so that as new products come out, folks can come here to the IOL and see that there's initiators and targets that we have, and we can run those same interoperability tests that we ran at the PlugFest. We can run in our lab against new products as they become available. The same conformance tests that we ran at the PlugFest, we can run those against new products as they become available in our lab. And so really our goal here is that PlugFest was just a launch point for this new technology. And it's really the first opportunity we had to qualify devices for this NVMeoF Integrators List. But the greater goal is that more products come through, more products get qualified for this Integrators List, and it starts to become a demonstration of wide industry interoperability. And so when people want to have a point of reference for NVMeoF interoperability and NVMeoF conformance, they can use this Integrators List. So some of the first companies that have qualified for this NVMeoF Integrators List you see here. You'll see these guys on the Integrators List that we're launching: Cavium, Mellanox, and Toshiba. So they were all happy to participate in the PlugFest and get listed up on that NVMeoF Integrators List. A little bit about the conformance test that we offered and performed. We actually have a software package built here at UNH IOL that does some of that, or does all of that, NVMeoF conformance testing. This is kind of built on the software package that we put together for regular NVMe over PCIe testing. And so we've adapted that and expanded that to cover NVMe over fabric testing as well. So this is a tool that we do NVMeoF conformance testing with. And again, it's available to our members. Folks can run it in-house and make sure that they're meeting all of the conformance requirements. As I said, a lot of this work is to qualify products for the NVMeoF Integrators List. So as I mentioned, that Integrators List has both interop and conformance requirements that I walked through earlier. You can go to our website right now and see the NVMe Integrators List and the NVMe Integrators List. We'll be turning on the NVMeoF Integrators List tonight prior to the press release going out. So a little bit of history so you understand where that Integrators List falls compared to the other NVMe Integrators List. The Fabrics Integrators List, that's the one that we're talking about today. That's the one that's going to be launching tonight. And that's going to be kind of the source for proving that products have been third-party tested at UNH IOL. It's a very good complement to the NVMe list, which we launched in 2012, now has over 100 products on it, primarily NVMe SSDs. And then also the NVMe-MI Integrators List that we launched in June of this year. So that's a newer one, not as quite as many products on that yet, but certainly a lot of interest in that. So a common question that people have is how do they get a product on the list? So some quick steps here for people to understand that. Highly encourage people to run that conformance test tool in-house and do some pre-testing in their own lab to make sure that they're meeting all of the conformance requirements. And again, we're happy to support people getting that turned on and enabled in their lab. We also encourage them to do their interop pre-testing with at least 2 different interop configurations. We've published the systems that we use to the NVMe community. We're certainly happy to help people get that set up in their lab as well. And so the goal of this pre-testing, both on the conformance front and on the interop front, is so that when people actually send a product to UNH IOL, whether that be as part of our weekly operations or part of a plug test, that they don't have any surprises, that they have confidence in their product actually being able to pass those tests. So a lot of exciting things happening with respect to NVMeoF and NVMe. As far as what's next, we're looking at planning another event in spring of 2018. And I think some of the things that you'll see there is we'll be expanding the conformance items. There's a lot of interest on new NVMe features that are being introduced in new specs. So we'll be covering some of those. We'll also probably try out some more complex interop requirements and possibly introduce some new fabric transports. I think that's going to depend on what kind of interest we see from the community, what kind of products are out there, and what kind of transports that people are interested in testing. But really, we've kind of designed this program and designed our tests to be fabric agnostic, just like NVMeoF itself is fabric agnostic. So that one kind of depends on community interest, but it's certainly a possibility. So that kind of covers the primary news that we wanted to talk about. I've just got a couple quick slides here on UNH IOL, who we are and what we do for those folks that maybe aren't familiar with us. So we're a neutral third-party lab. We're located here at the University of New Hampshire, 100% funded by commercial industry. So all of the services and the test tools that I described, those are services that we provide to companies. That's what provides the funding for this lab to exist here at UNH IOL. And we've got a fairly extensive reputation on doing interop and conformance testing. We've been here since 1988. And our primary goal across all the industries that we operate in is to enable multi-vendor interoperability. And so because of our neutral position and because of our position in creating tests and creating interoperability programs, running these plug tests, we actually get some interesting insights into what's happening in industries and can actually feed that back into the various standards bodies and forums to help them to improve their products and improve their specifications. So a little bit of that here. So we work directly with standards groups. In some cases, work directly with end users. So there, think about the solution providers. Think about even hyperscale data center implementers. We're talking with folks there to see what kind of testing is going to be important to them. And all those things we can feed back to the developers and the engineers, refine our tools so that it's useful to the engineers that are trying to test this stuff on their bench. And of course, the big thing we provide is reports on all of this. So all the products that we've tested and are listing on the integrators list, we also provide a report to that company showing the testing that was performed and documenting that. And that's something that they can use to either for their own internal debug and R&D, or it's something that they might want to share with their customers to show that their product has been third-party tested. Now, we are at the university, so the other side of things is we've got lots of electrical engineering and computer science students here at the lab that kind of do that testing day in and day out. We provide training to them. And the idea there is that these students, yes, they're doing their classwork, they've got their homework and projects and academic work that they're doing. Then they come over here to the lab and they can actually apply that stuff on real equipment, on real problems, on real products, and also interface with engineers that are out there in the industry working on these real products, and really just have a really good experience in learning how these products work, learning how the industries work, and also make some good contacts in the industry and try and figure out what kind of work do they want to do. It really opens up a lot of doors for our students. That's kind of the other side of things that we do. As far as industries that we work with, there's a bunch here. You see NVMe in there, you see FCIA in there. a lot of other industries across the networking, telco, and storage, lots of different forms and standards bodies that we work with. So that kind of brings us to the end of the news, and we've got to our questions.
Yeah, thank you again, David. We're now going to begin answering some questions that we've had submitted during today's press conference. As a reminder, you can still submit your questions through the questions box in the control panel. We do have some questions already submitted. We have one here from Rick. Once I send a product to the UNH IOL, how long might it take to achieve the listing?
Oh, okay, yeah, that's a pretty easy question. Usually, so first we have to do the testing, of course, and that's why we encourage folks to do the pre-testing so that there's not any surprises. Usually the testing might take about a week to do from start to finish, from product arriving here, going through the interop test, going through the conformance test. If everything's passing, that takes about a week. And then from there, it's just a matter of getting the approval to from the company to actually list a product on the integrators list. So there are times when companies come through maybe early in their development cycle and they're not ready to actually list a product, even if it qualifies. It might still be a pre-release product. So short answer, we can do it in about a week, but there are times when people want to do the testing and then, hey, the product release isn't for another month. And so we'll kind of sit on that information until they actually do their product release and then put it up on the list. But generally about a week.
So we have another question here from just the general lab community. What are the next steps for NVMe-oF testing?
Yeah, so I think next steps there, at our next Plug Fest, I think you're going to see a deeper dive into the conformance test. So NVMe organization, they released their NVMe 1.3 spec in, I think, spring of 2017. And so I think there's going to be a lot of interest in seeing some of those features that have just now been, or relatively recently been introduced into the specification. You're going to see some of those things being tested over fabrics. So that's one thing that I think is the next step, is making sure that we've got all of the relevant NVMe features being tested over the NVMeoF fabric. Other things are, like I said, perhaps new transports. So there's a lot of interest in NVMeoF even using TCP. So depending on the community interest and depending on the type of products that are available at the time of the Plug Fest, you might see some of that showing up. But again, that kind of depends on where people are in their product development. But I think those are the two things as next steps: new transports and also new conformance items.
So we have another question here. Is there anything challenging or unique about installing this equipment?
Yes. So, NVMe itself, just taking a step back and just talking about NVMe for a second, it is very straightforward to install. All the major operating systems have inbox drivers for it. And so, and of course, everybody's got PCIe interface on a motherboard. So if I'm trying to install an NVMe add-in card into a server or into a desktop PC, that's almost as plug and play as you can get at this point. NVMeoF is certainly more complicated because there's more pieces, right? So you've got the initiator, and so you need to have an operating system that actually is going to support NVMeoF drivers. So there's several Linux distributions out there that have that in box right now. So I know SLES does, Ubuntu does. So that's one thing, is making sure that you've got an operating system that has built-in support for that. Of course, you also have the switches, whether they be Ethernet switches when you're doing a Rocky setup, or fiber channel switches for doing a fiber channel setup. And then, of course, the target. So same issue on the target side. There's folks that are making all-flash arrays that are kind of a completely integrated, completely dedicated NVMeoF solution that you could just drop onto an FC or Rocky network. And then there's also silicon providers out there that have enabled for their NICs and HBAs to operate in an NVMeoF target mode. So there's some parts there, some complexity just in the variety of components. The other thing that's a little bit of complexity is tuning these things for performance. And I think that's something that there's a lot of work to be done on in understanding what exactly is the workload, and then how exactly do I tune, especially my Rocky network, to get the best performance for that. And so that's something where there's probably some more work to do. And it's hard to answer that or really provide solid guidelines industry-wide for that, because a lot of it's going to depend on the customer workload in terms of how do they want to tune their fabric for the best performance. So there's definitely some complexities there, but when you tune that properly, you can get really good performance taking advantage of those NVMe drives that have such low latency and such high performance. So the network's got to be tuned properly, and that's a real challenge.
So we do have enough time for just one more question. And if you do have further questions after this conference, please feel free to reach out to us. So this last one from the general lab community again, is the testing available now?
Yes, it is. Yeah, the Plug Fest that we did early November, that was the launch point for it. That was kind of the kickoff, the first time it was publicly available. But yes, the testing is available now. Folks can get their hands on the Conformance software now, do the pre-testing, send products into our lab, and qualify for the list. Yep, it's ready to go now.
Great. Well, thank you again, David, and thank you again to everyone who attended today's press conference. Just another reminder, the PR is under embargo until 12:01 tomorrow. Today's conference for NVMe over Fabrics test services now available at the lab, as well as NVMe over Fabrics Integrators List launch. We appreciate your time. The hashtags for today's conference again are hashtag NVMe, NVMeoF, and UNH IOL. Just a reminder again, if your question was not answered, we will follow up, or feel free to contact us directly. We have Melissa Power at Interpros, or of course David from the IOL. Everyone should be getting a recorded version of today's press conference. And on behalf of the UNH IOL, thank you for joining us today, and we hope you have a great rest of your day.